Okay, I'm only going to do section 8.2, but I'm going to go through just the summary for section 8.1 because all this stuff we'll use in 8.2 also. 8.1 doesn't really have any math in it exactly, and no calculator stuff. So I think just the once I release the answers, I bet most people can just read the answers and that'll make sense. But if any questions don't make sense from 8.1, we'll go over those on one day in class. So, okay, so here, just real quick, going over the summary for 8.1. Just this idea of like a point estimator. When they say a point estimator for a parameter, it's just some value from a sample, which is a statistic, that we'll use to estimate the parameter. Okay, the specific value of the point estimator is called the point estimate. So there's a point estimator was just this general idea of something that a type of statistic that you're going to use from a sample to generalize and estimate a parameter with. And then the actual value of the point estimator is called the point estimate for a given sample. Okay, and then to get a confidence interval, you'll find your point estimate from your sample and then calculate your margin of error, and we'll do that in 8.2. But the general form that always works for any confidence interval is statistic. You take your statistic. For us, it'll be means and proportions. And in 8.2, it's just proportions. And then you'll do plus or minus your critical value. This is based on the confidence level, that Z star, and then times that by the standard deviation of the statistic, which we know is called the standard error. Or at least for us, will be the standard error. Okay, and then I gave these. So these are like the interpretations you'll use. Let me fix this. I'll put these up here. Okay, so these interpretations, when you're interpreting a confidence level, if we take many samples and calculate a confidence interval for each, about whatever the confidence level is of them will capture the true whatever parameter and context is. Okay, so this interpreting the confidence level is just saying that some percent of the confidence intervals that you create for different samples, about a certain percent, whatever the confidence level is, a certain percent of those confidence intervals will actually include or capture the actual parameter, whatever that is. Okay, interpreting the confidence interval. So once you find your interval, from A to B, you'll say we are, whatever the confidence level is, percent confident that the interval from A to B captures the parameter and context. Okay, and then the only other thing down here is margin of error of a confidence interval gets smaller as the confidence level decreases and as the sample size increases. Okay, so a smaller margin of error will make a smaller confidence level and will margin of error will decrease as the sample size increases. All right, and then remember, margin of error for a confidence interval only accounts for chance variation because it's based on a sample, and samples have variation, but not other sources like non-response and undercoverage, which we can't account for. So there is maybe a wider margin of error, should be, if your sample was taken in some way that had bias, then obviously that would change the margin of error. But okay, so I just want to go through 8.1 because we'll actually do all this stuff in 8.2 also, but I'm not going to do any actual problems in 8.1 in this video. So okay, so just going to go through this super quick, this summary. When we construct a confidence interval for a population proportion, we need to ensure that the observation and the sample can be viewed as independent, and that's what the 10% rule will do, and that the sampling distribution of p hat is approximately normal. That's what large counts does. Randomness, if we, because we're always conducting a confidence interval for a sample, so you have to make sure that your sample was came from a sample that was randomly produced, so that we can generalize it to the population. Okay, and then for us, for now, for 8.2, when the conditions are met, the procedure that we'll do to find our confidence interval will be a one sample z interval for p. Okay, so one sample, because we're only finding a confidence interval for a single sample. If you are doing a difference of samples, a difference of proportions, or a difference of means, that would be a two sample, because you'd be finding a statistic for each sample, subtracting them, and then creating a confidence interval for that, but we're not doing that. So we're just doing one sample, and from that one sample we'll get p hat, and it's called a z interval because anytime you do proportions, this critical value is called a z value. So and then we're doing it to estimate where the population parameter is, and that's p. Okay. And then this is standard deviation when it's p, but when it's p hat, it's just same idea, but called standard error. Okay, and then when we're asked to construct and interpret a confidence interval, always have to follow these 4 steps: state, plan, do, conclude. So state the parameter that you want to estimate and the confidence level. Plan, identify the appropriate inference method. For this section, it'll be this one sample z interval for p. And then check the conditions for us for 8.2 when you're constructing a confidence interval for population proportion. These are the 3 conditions that you have to check to make sure that are met, and that's all in the plan section. Do, if the conditions are met, we'll perform our actual calculations, and that'll be in the calculator, and then we'll interpret our results. So okay, and then that's the interpreting confidence interval. Okay, and then we'll kind of do this. The last couple problems are ones where we'll have to do something a little different, maybe solve for z or solve for the standard error or something like that. Some kind of different question that they'll ask for. But we'll kind of do that in the last couple problems. And also, I'm only going to do certain problems. I'm only going to do mostly the problems that require a calculator. I feel like the other problems, just the textbook explanation is good enough. And again, just like for 8.1, the fact that I'm not doing a video for that, for any questions that I don't do in the video, we can ask another day. Okay, so 36 is the first problem I'm going to do. So they say reporting cheating. Okay, what proportions of students are willing to report cheating by other students? A student project put this question to a simple random sample of 172 undergraduates at a large university. Okay, you witnessed 2 students cheating on a quiz. Do you go to the professor? Okay, only 19 answered yes. Assume the conditions for inference are met. Okay, so part A says determine the critical value for z star for 96% confidence interval for a proportion. Okay, so anytime you're doing a certain confidence interval for a proportion, you're finding z star, and this critical value z star is based only on the confidence level, which is 96%. Okay, so 96% is the only thing we need to know as far as the confidence level to find this critical value. Okay, so let's go to the calculator for this. I'll put it maybe right here. Okay, and when you're doing this, we'll go to inverse norm. I'm going to show two different ways of doing it because uh, there's two different calculators um, kind of setting or ways that the calculator does inverse norm. If you have like an older calculator, you have to do it a certain way. Newer calculators, you can do it an easier way. But I'm going to do it the harder way, I guess, for all of them. Uh, Kind of for a certain reason. It's kind of easier to copy the answer in the calculator. And the simple way is so simple that I'm going to show it once, and that'll be simple for people that have a newer calculator. Okay, so determine the critical value for 96. So here, we'll do the first, let's look at the first one. So we'll do second vars, which is distributing, just like for a normal CDF, and then go down to inverse norm. And so here, if they want a 96% confidence interval, the easy way is just make the area 0.96, whatever the confidence level is. Here, we're always doing the mean and standard deviation to be from 0 to 1 because this is all really based on z-scores. This is giving us z-scores as answers. And when you're dealing with z-scores, those are the standardized scores, and the mean and standard deviation of z-scores for a certain distribution is always 0 and 1. Okay, so if we keep going, if for the people that have these options, tail, and this one says center, you can't see right now, and then right. For the ones that have these options, not everyone does though, for these calculators though, if you want to just find the z star right away, the critical value, just this is the exact confidence level that they give you, and then just use center. Okay, so let's see that actually. Here, let's finish this. Okay, so do center, and that's it. Just hit paste. Oops. Okay, now the positive value over here is the critical value. So the only problem is you have to like retype it, which isn't a big deal. But if you're going to do math to find your confidence interval, where you do the point estimate plus or minus the critical value times the standard error, you have to retype this. But okay, so that's one way to find the critical value. And here, let me write that down. So for a 96% confidence level, Z star, which is our critical value, equals that value, that just the positive version. And that'll always, notice it's always the same value here, or it will be the same value if you do the center. But one will be negative and one will be positive, but we'll just use the positive value. 0.05375. Okay, so that's probably good enough. Okay, so let's do it the other way, and I'm only going to show, I'm going to do it this other way every time. All right, so the other way to do it is, so in the calculator, when we did it just now, there was left, center, right. If you don't have those options, it's assumed to be left. And so I'm going to do, in my calculator, I'm going to do the left every time, which is what the older calculators assume to be anyways. Okay, so if we're doing it the other way, so I'll just kind of do this. So let's say we have a normal curve. Oops. Okay. And then we want to find, so if we look at this, we want to find if all this area was 0.96, this is the mean, and we want to find what would this would be our z star that we're looking for. So this value here, and this would technically be negative z star here. And that's just all this area. That'll be the the z-scores associated with 0.9% of the area being in between two values, negative and a positive value. Okay, so but if we're doing a 96% confidence interval, but if we're finding the z-score associated with 0.96, this z-score here, there's not 0.96 area to the left. There's more than that because there's this little area here. So like this little area here is, first off, the same as the area on the right. And if this is 0.96, there's 0.04 if you do, I'll do it here, 1 minus 0.96. So that's 0.04. And then if you divide that by 2, 0.02. Oops. Okay, that's how much area is on the left and right. So there'll be like 0.02 here, and then 0.02 here. Oops. Okay, sorry, I had to do something, so hopefully this makes sense coming back. Yeah, so this z-score is associated, 0.96% of the, or 0.96, this area is within, goes from negative z to z. But if we want to do the left inverse norm, or what your calculator defaults to if it's an older calculator, you want to add up all this area. So all you do is take the confidence interval, subtract it from 1, divided by 2, and then that's what you have to add to this area. Okay, so the area that we'll use if you go from the left, or if you have an older calculator, is you'll do this little expression, find this, and then add it to the whatever the percent is as a decimal. Okay, so for this, let's go back to the calculator now. So we'll do it the other way. Okay, and I'm going to do it this way for all of them. So we'll go back to inverse norm number 3. And so now we'll do 0.98, right? 0.96 plus 0.02. And then still 0 and 1, and we'll do left. And notice it gives us the same value. Okay. Okay, so that's our critical value for part A. And this, technically you could memorize this. So this would be the critical, and this one you wouldn't memorize for 0.96, but the critical values for 0.90, 0.95, and 0.99 don't change ever, So, okay. Okay, so that's for part A. For part B, it says construct now a 96% confidence interval for the proportion of all undergraduates at the university who would go to the professor. Okay, so for part B, we'll take to set up a confidence interval. In general, we'll always do our point estimate, and this is what we'll get from the statistic from our sample. Move this up here. Oops. Okay, I don't know what to do with that. Actually, let me move this down here a little bit. Okay, yeah, so we'll do our point estimate. And then we'll do plus or minus our critical value. Okay, and that's based on our confidence level. That's the z-star that we get from inverse norm. And we'll times that by the standard error. Okay. Technically standard deviation of the statistic, but that's called standard error. Okay. So for us, our point estimate from this problem, so they said 19 out of 172 undergraduates would answer yes. So that's our proportion p hat. Okay, the critical value is what we just got, which would be that 2.0535. Okay, and then now we just have to get our standard error, and that's our standard deviation equation, but with using p hat instead of p. Okay, so let's actually, and actually here, let me finish. So this will be whatever our p-value is. Actually, let's get that p-value in the calculator real quick. So that's just, I'm going to store this value as a, because we'll use that later when we're constructing our confidence interval. Okay, so first let's find our 19 divided by 172 as a decimal. Okay, so that's our p hat. Okay, so I'll just do 0.11. So we do p times 1 minus p, or p hat times 1 minus p hat. Okay, and that'll be all over our sample size. Okay, so this is what we'll use to construct our confidence interval. Okay, so the rest we'll just do in the calculator. Okay, so we're constructing our confidence interval, we'll do the standard error first. Oops, so we're using that. So I'm using the exact value, and then we can do 1 minus that same value. Okay, so this will be our standard error. Okay, now to do our confidence interval, we'll go up, get that p hat. Oops, which is that 0.11. Good to grab that. And I'm going to do the minus first, and then we'll do the plus. So that, remember, a was our critical value. Up here, I stored it as a, so this is the critical value. And we're going to do that times our standard error here. Oops. Okay, so that's the left endpoint of our interval. And then notice you can just grab that with the minus one, because the intervals that you get is by doing plus or minus the margin of error. And so this was the minus version. And so just go up here, highlight, and hit enter. It'll bring this down. And we'll just change this minus to a plus. And I'm going to do that every time. I think that's like the quickest way to do this. So change that to a plus. And that'll now be the right-hand side of our confidence interval. All right. And so that's our confidence interval. So notice, so that goes from confidence interval, that goes from 0.061, round to the thousandths, to 0.160. Okay. All right, and then interpreting, I'm going to skip that. That's in the part C, says to interpret the interval. I'm going to skip that. I'm going to skip some of the stuff that the answer key gives a better answer than I would give even. So, okay, so that's our confidence interval there. Okay, so for 38, it uses the same prompt. So they say calculate and interpret the standard error. Okay, so we already did that. So our standard error is up here in the calculator still. So here, so I'll just write it down first. So that's standard error of p hat. It's a notation. Will be 0.024. Oops. Okay, and then they say to interpret, and then that's in the answer key also. So I'm gonna leave the answer key to do the stuff that is they would do better than I would, and you can just read it and it'll make sense. So okay, so I'm gonna do just part C for number 40, and then I'll do number 48. The rest, the answer key answers really well. So okay, so for part C, or for really this whole problem. So they say student body president of a high school claims to know the names of at least 1,000 of the 1,800 students who attend the school. Okay, to test this claim, student government advisor randomly selects 100 students and asks the president to identify each by name. Okay, president successfully names only 46 of the students. Okay, so that's our sample, 100, and in that sample, the student body president could only name 46, which is less than the proportion that he claimed. I don't know what that is, 1,000 out of 1,800, whatever that is, but that's more than half for sure. It's about 2/3, I think. And he only, in the sample, could name 46%. So, okay. So, construct a 99% confidence interval for P. Okay. So, in parts A, we identify the population parameters. Part B, we check conditions. All the conditions were met. You can check the answer key for that. So for part C, okay, we want to figure out our critical value. I'm going to kind of reiterate this. Actually, no, I'm not. Okay, I'm just going to do it for this. Okay, so for part C, the start out with the critical value. That'll be the 0.46 that we get from the sample. Okay, it'll be plus or minus the critical value associated with a 99% confidence interval. Okay, so let's do that in the calculator. So we'll do inverse norm. Okay, and actually define that area. So let's do that off to the side every time. Okay, define the area. Okay, a normal curve. Okay, we have this negative z star to z star. And 0.99 of the areas in between. So if you do 1 minus 0.99 divided by 2, this is 0.05, and that'll be like this little area here is 0.05. Okay, so when we do, I'm going to do to the left in the calculator over here, and so when we do to the left, it'll be 0.99 plus 0.05, so that'll be 0.995 to the left. Okay, but remember, if you're doing center, you just do 0.99, just whatever the confidence interval is, or confidence level. Okay, yeah, so that's our confidence interval. The book interprets it for part D, so I'll let you look at the book's answer for that part. Okay, and then 48, so let's do 48 now. They say use your interval that we just got from problem 40 to construct and interpret a 99% confidence interval for the total number of students at the school. Not the proportion like we just found, but for the total number of students at the school that the student body president can identify by name, and then use your interval to evaluate the president's claim. So I'm just going to find the confidence interval, and then you can read the answer for the rest. Okay, so the only thing you really have to know is this is a confidence interval for a proportion of the population that, we can be 99% confident that the true proportion of students that the president body can name is in this interval. Okay, but this is proportions of the population. So if the population is 1,800, we can do 0.332 times 1,800, and then 0.588 times 1,800. And then this will give us the actual number of students at the school instead of the proportion. Okay, so if we do each of those in the calculator, if we do 1,800 times 0.332, really times the exact value that we got in the calculator, you get 597.6. Okay, we'll round that to 598. And then if you times 1,800 by 0.588, you get 1,058.4 to 1,058. So now our confidence interval for not proportion but number of students will be 598 to 1,058. Okay, and then you can look in the book for the rest. Or not in the book, in the answer key. Okay, so let's do 42. So September 11th, a recent study asked U.S. adults to name 10 historical events that occurred in their lifetime that have had the greatest impact on the country. The most frequently chosen answer was the September 11th, 2001 terrorist attacks, which was included by 76% of the 2025 randomly selected U.S. adults. Okay, construct and interpret a 95% confidence interval for the proportion of all U.S. adults who would include the 9/11 attacks in their list of 10 historic events. Okay, so when they say the phrase construct, so up here, when they say here this construct and interpret a certain confidence interval, so we're going to do the whole thing where we do state, plan, do, conclude. Okay, so first thing is state. Okay, so we're stating the confidence level by a percent for our confidence interval, and then we'll state what the parameter is in context. Okay, the book does it, but I'm going to do it. I'm going to do this one just to see how it's done. Okay, so first we'll state they said it was a 95% confidence interval. For P. Okay, and that's the true proportion of adults who would include the 9/11 attacks in their list of 10 most influential or 10 historic events that have affected the country the most. So we'll say P, so this is the true proportion, of U.S. adults include 9/11 on their list. I'll just say their list of historical events. I'll just say list, okay. Okay, so that's the state part. So we stated the confidence level and describe what the parameter is that we're trying to capture in our confidence interval. Okay, so that's the state part. So now we'll do plan. I'm going to run out of room quickly, but that's okay. Okay, so this, so we'll state what procedure we're using. So it's a one sample Z interval for P. Okay, and then we'll check the conditions. So first random. Okay, they stated in the problem 2025 randomly selected adults. So we'll just say check. Okay, 10% condition. So 10%, we'll say the sample was 2025, and that's less than a tenth of all U.S. adults. Okay, and then the law of large counts. So we'll do, oops, what was our P? Okay, P was 0.76, so if you do 0.76 times 2025 and 0.76, or sorry, actually, let me do it a different way, sorry. So it's 2025 times 0.76 and 2025, the sample size, times 1 minus P hat. Okay, the first one ends up being 1539. And the second one ends up being 486. Okay, but each of these are greater than or equal to 10. So that checks out for law of large counts. Okay, so all the conditions are met. Okay, no real room to do the rest, so I'm just going to do the rest in the calculator. Okay, so I'm going to do now the do part, and then, technically I'm doing do, but I'm going to do that in the calculator since I don't really have room in here. Okay, so let's go to the calculator now. Make sure it shows up. Okay, so now we're going to actually construct the confidence interval. So first thing is to find Z star. This is a 95% confidence interval. We'll do that inverse norm. Okay, and then for 0.95, there's 0.05 area on either side, and so that'll be, divide that by 2, that's 0.025, and if we add it, I'll let y'all do the rest, and I think the answer key does it also, 0.975. Okay, that's to the left. Okay, that's our critical value. Okay, now we'll find our standard error. We'll do P hat, which is 0.76, times 1 minus P hat, and then all over that sample size of 2025. Okay, so that's our standard error. Okay, now for our confidence interval, we'll do our P hat, do the minus first, and we'll go up and grab the our critical value, Z star, and then times that by the standard error. Okay, and then just to see what we did, when you do your critical value times your standard error, the whole thing, critical value times standard error, is the margin of error. So these two things multiplied to be the standard error, to be the margin of error. Okay, so let's see, that's the minus part. Okay, so that's the first endpoints, and I will change that minus to a plus to get the right-hand side of the interval. Okay, and that's our whole interval. Okay, so our confidence interval, and I have to write more, but I just don't have room, but so that'll be 0.741 and then 0.779. Okay, oops. Okay, so that's our confidence interval. All right, and then technically we would have to do our conclude, so interpret this interval, but I'm going to leave it to the book to do. Not enough room anyways. Okay, and then I'm not going to do 44. The book does 44 really well, so I'm going to skip that. Okay, so I'm going to do part A. Okay, so they say in part A, they say construct and interpret a certain confidence interval. Okay, so we'll have to do the state, plan, do, conclude. Let's start out with state. Actually, let me read this problem. It was really short. So, okay, according to a recent study by the Annenberg Foundation, only 36% of adults in the United States could name all three branches of government. Okay, this was based on a survey given to a random sample of 1,416 U.S. adults. Okay, construct and interpret a 90% confidence interval for the proportion of all U.S. adults who could name all three branches of government. Okay, so first thing is just stating the confidence level and the parameter. Okay, so they told us this was a 90% confidence interval for P, which equals the true proportion of U.S. adults who can name all three branches of government. Okay, so that's the state part. So let's do B. So now we'll do that state, and now we'll do plan. Okay, so the procedure that we're using for proportion right now is a 1 sample Z interval for P. Okay, so to check conditions, so random. They say in the problem, this was based on a survey given to a random sample. So I'll just check mark that. Okay, and then the 10% condition, the sample was how many people? 1416. So 1416 is less than 10%, which is a tenth of all U.S. adults, which is where the sample came from. So that's a 10% condition. Okay, and the law of large counts, we'll do n times p and n times 1 minus p. So n is 1416 times p, which was 0.36. And then 1416 times 1 minus p. Okay, and these are both greater than or equal to 10. One is like 510, and the other is 906. Okay, so these are both greater than or equal to 10. So law of large counts. Okay, so those are our plan. So now we'll do our do. Okay, Okay, so now we'll actually construct the confidence interval, so we'll do this in the calculator. Okay, so let's look at the calculator down here. Okay, so first this is a 90% confidence interval. So if we construct, here I'll do this for this real quick, just to see. So if you have a normal curve, I'll do it in the upper left up here. Okay, 90% of the data is in between here. Okay, so we really want to figure out what this little area is here, so that we can add it to 0.9, and that'll be what's to the left of this Z star here. That value there. Okay, and all you do is do 1 minus 0.9 divided by 2. So 1 minus 0.9 is 0.1 divided by 2 is 0.05. And if you do, so our Z star that we'll use is going to be 0.05 plus 0.9, and that's our Z star. Okay, so let's go back to the calculator. Okay, and that's what we'll put in the calculator, 0.95. Okay, remember, if you have the option to do center, you can just do 0.9 and then center. But I'm going to do this. Okay, so that's our Z, oops. That's our Z value, Z star value, our critical value. Okay, so let's find our standard error now. Do square root P times 1 minus P. Now all over our sample size, which was 1416. Okay, that's our standard error. So now we'll do our point estimate, 0.36. We'll do the minus first. That's our Z star critical value times that by our standard error. That's the margin of error. Okay, so our confidence interval, the left will be 0.339. Okay, let's go back to the calculator to get the right hand side. So go up and highlight, just change the minus to a plus. Okay, and that's the right hand side of our confidence interval. Okay, and then part D is the conclude part. Okay, and this is where you interpret this confidence interval in context. So you would say something like, we're 90% confident that the interval from 0.339 to 0.381 captures P, which is the true proportion of U.S. adults who could name all 3 branches of government. Okay, so these last ones are a little different, starting with number 50. So yeah, so I'm going to do both parts of this one. Okay, they say, can you taste PTC? So PTC is a substance that has a strong bitter taste for some people and is tasteless for others. The ability to taste PTC is inherited. About 75% of Italians can taste PTC, for example. You want to estimate the proportion of Americans who have at least one Italian grandparent and can taste PTC. Okay, how large a sample must you test to estimate the proportion of PTC tasters within 0.04 with a 90% confidence? Okay, so 0.04 in this context represents the margin of error. So we want the margin of error based on a 90% confidence interval. We want the margin of error to be less than or equal to 0.04. And then they go on to say, answer this question using the 75% estimate as the guessed value for p hat. Okay, so 0.75 will be our point estimate will be our p hat, and so we'll use that in our standard error. So, okay, let's do this by hand first, and then we'll go to the calculator. So A. So we want our margin of error. Okay, so our margin of error is our critical value, Z star. Actually, let's find that first before we do anything. Okay, so let's go to the calculator down here and find that Z star that's associated with a 90% confidence interval. Oh, actually, sorry. Oh, here, I recorded this earlier, so here, we'll find the, oh, whoops. Okay, I must not have done the calculator, but the Z star associated with a 90% confidence interval is 1.645. So I must not have done that. Okay, and then we'll times that by our standard error, p hat times 1 minus p hat. Okay, all over our sample size, but this is what we're looking for. Right? How large a sample must you estimate? So that's unknown, our sample size. Okay. And then this represents the margin of error. Critical value times standard error is margin of error, and they say they want this to be less than or equal to 0.04. Okay, so first thing is we want to solve this for n by hand, and then whatever we get, we can type that into the calculator, and that's what I started to do down there. I just forgot. Okay. So think about it when you're doing algebra. First thing, if you're solving for this n, we'll divide by this, and then we'll square both sides. So if you, I'll kind of go in steps. So we'll do 1.645. Oh, whoops. Do 0.04 divided by 1.645. Okay, that's just kind of dividing both sides by this. And then now we'll square both sides, and that'll get rid of that square root. Square. Okay. Actually, I'm sorry. Here, what's the best way to do this? I'm kind of, there's like not that much room. Hold on. Let me do this a different way. Move this. Move this over here and give myself more room. Okay, so let's do this algebra, solve this. Okay, so we'll basically that'll cancel that out, and then we'll square both sides after that. Square both sides, and square both sides. Okay, and then the square and the square root will go away. Okay, so that means we're at the point where 0.75 times, really 0.25, 1 minus 0.75 over n has to be less than or equal to 4 over squared. Okay, and then basically we're going to do two things. We're going to times by n to get the n over here, and then divide by this to get this under here. Okay, so it's going to be 0.75 times 0.25 divided by this squared fraction is less than or equal to n. Okay, and that really just means n is greater than or equal to this. Okay. And then another way to write this is, there's like not much room. It's so weird, so annoying, but so this is kind of keep, change, flip. where you're dividing by a fraction. I know it's squared, but you're still dividing by a fraction, and you can times by the reciprocal squared also. And I'm going to kind of switch it. So first off, I'm going to write the n first, n is greater than or equal to. Okay, so switching this to be that, and then it's greater or equal to this, which is this flipped. So that'll be 645 over 0.04 squared, and then times that by the top. So you're doing keep, change, flip. So keep the top the same, change it to multiplication, and then flip this fraction. Even though it's squared, you can still flip it. And this will just be 0.75 times 1 minus 0.75. 0.25. Okay, so let's go back to the calculator now. And that's what I was doing there. Okay, and we know that's 0.25, but I'll do it just so people can see clearly that's part of that. Okay. Okay, and then okay, so that means our sample size, in order to have our margin of error be within 0.104 or 0.04, sorry, with a 90% confidence interval, the sample size that we have to use has to be greater than or equal to, so we have to have greater than or equal to 317.1 people, and this is actually number of people now in an actual sample, and that has to be a whole number. Okay, so then we'll round this up to 318. Okay, so how large would our sample? So our sample would need to test at least 318 people. Okay. And it's really 318 people with at least one Italian grandparent. Okay. Okay, so that question was a little different. Okay, now they do this. They say do the same thing. Okay, actually, let's read part B now. So they say answer the question in part A again, but this time use the conservative guess, p hat equals 0.5, and by how much do the two sample sizes differ? Okay, so instead of using 0.75 like we did originally, we're going to use 0.5 and then 1, so we'll use 1 minus 0.5. So the only things that are going to change is this will be 0.5 and this will be 0.5. Okay, so for part B, I'll do part B down here. N is greater than or equal to this exact same thing as before, so I won't redo the work for this. This will be 0.5 times 0.5. Okay, so let's go to the calculator to do that. Okay, and I'm just going to grab this and bring it down and edit it because it's so close to the original. And the part B is so close to part A. Okay, and that's it. Okay, 422.8. Okay, so that'll round to 423. Okay, so if we're using the most conservative estimate, then we'll say that our sample, using it's the most conservative estimate for p hat, we're estimating p hat, and the most conservative estimate is 0.5. Okay, our sample would need to test at least 423 people with at least one Italian grandparent. Okay, so I'll do 52, election polling. So Gloria Chavez and Ronald Flynn are the candidates for mayor in a large city. Okay, we want to estimate the proportion P of all registered voters in the city who plan to vote for Chavez with a 95% confidence and a margin of error no greater than 0.03. Okay, how large a random sample do we need? Okay, notice there's no sample, there's no point estimate that we can use. There's no kind of estimated proportion of people that would vote for, registered voter who would vote for Chavez. So when we have no idea, no point estimate that we can use, we use 0.5 as the conservative estimate. Okay, so it's going to be similar to the last one, where first off, I won't do this in the calculator, but the critical value, the z star. So associated, what did they say? 95%. The z star associated with that, you can do inverse norm and do that whole thing. Ends up being 1.96. And worth memorizing. I don't have it memorized, but worth memorizing if you're a student, I think. I should memorize it, but. Okay, and then, so we want the margin of error now to be within 0.03. So we'll do the same thing we did last time. Okay, so we want our margin of error, which is our critical value, z star, which was 1.96. Okay, times our standard error. We'll do 0.5 times 0.5. When you don't have a point estimate, that's the most conservative, and that's the one we'll use. And we want this margin of error to be less than or equal to 0.03. That'll make sure that the margin of error is no greater than 0.03. Okay, again, we can divide both sides by 1.96. Cancel, and then square both sides. And you get, I'll kind of come back over here. You get 0.5 times 0.5 over n less than or equal to 3 over squared. Okay, and then we'll divide by this and multiply by this, so this will end up being on the bottom of this fraction, and this n will be over here. So I'm going to do that to the right. Okay, so we'll do 0.5 times 0.5 divided by this whole thing. Actually, oh yeah, that's fine. And this is less than or equal to n. Okay. Okay, and then last thing, so we'll say that means n is greater than or equal to this times the reciprocal of this squared. So I'll do the reciprocal first. So that'll be 1.96 over 3 squared times 0.5 times 0.5. Okay, so let's do that in the calculator. So you can see some part you have to do by hand with these, and then the rest you can do in the calculator. Okay, so first we'll do inverse norm. So actually I did inverse norm for this, I guess. I forgot, but I did. Okay, so this is with a 95% confidence interval. So to the left would be 0.975. Okay, and that's how we got the 1.96. Okay, so now I'm going to type in that expression that we solved for. Okay. Oh, and then do you notice that when I brought that down, it's missing a 1 right here? So I don't know how that happened, but yeah, so I just cleared it and started over. But it happened again. So just showing you how things happen like this. And so I just figured I'll edit it and just insert a 1 there. I don't know why it didn't. I don't know if other people had the same problem, so I kept that in the video. Okay, so just add a 1 there, or just type it in by hand if you have to. Okay, I don't know why I did that, just to show work. Okay, and that's it. Okay, so that means our sample size has to be, let's go back. Okay, so our sample size has to be at least 1,068 registered voters in the city. Okay, and that's what it says. How large a random sample do we need? We need n to be 1,068. That would be our answer. Whoops. Okay, so this will be the last problem I do in the video. So, okay, 54 says gambling and the NCAA. Okay, gambling is an issue of great concern to those involved in college athletics. Because of this concern, the National Collegiate Athletic Association, NCAA, surveyed randomly selected student athletes concerning their gambling-related behaviors. Of the 5,594 Division I male athletes who responded to the survey, 3,547 reported participation in some gambling behavior. Okay, this includes playing cards, betting on games of skill, buying lottery tickets, betting on sports, and similar activities. Okay, a report of this study cited a 1% margin of error. Okay, the confidence level was not stated in the report. Okay, use what you've learned to estimate the confidence level, assuming the NCAA took a simple random sample. Okay, so that's them assuming that the conditions are met. Okay, because the other conditions are going to be obviously met besides random. Okay, so we just want to make sure our margin of error is 0.1 or is 1%, which is 0.01. Okay, so let's give so our margin of error is going to be our z star value. Okay, and then it's going to be times and okay, first off, we want to find the confidence level, and the confidence level is just associated with z star. So the first thing is to find z star, and then once we find z star, we'll see how we can use that to find what the confidence level is. Okay, so z star is unknown because the confidence level is unknown. Okay, so we'll do z star. This is really what we're going to be solving for. Okay, and then we'll use the point estimate. So our p hat for this is going to be the 3547 out of 5594. And that's the proportion of the sample that said that they'd had some type of gambling behavior. I guess guess that year or whatever. Okay. And that ends up being 0.6341. Okay, so that's the p-hat we'll use. Okay. And then our sample size was 5594. Okay, and this is critical value times standard error, which is margin of error, and we want that to be 0.01. Okay, so first thing is z star is really just 0.01 divided by this whole thing. Okay, so let's do that in the calculator. Okay, so yeah, so first here, I'm going to get the p-hat, so that's what we got. And then I'm going to use that exact value when I'm finding this z star. So yeah, it'd be our 0.01. And there's like a little weird thing that happens. I'll show you. Okay, so now I'm trying to put that there, but you see how it doesn't go underneath the square root? Right, so let's clear it, and I'm going to store this as a letter. I'll store this as A. So A is p-hat now. So now when we do our solve for z star, and we're doing on the bottom is that square root is the standard error. Now we can just use A, which is P, and then 1 minus A, which is 1 minus P. Okay, so that'll give us the exact value for z star. And then that's our sample size. Okay, so that's our z star. Oops. Okay, so now we want to go backwards. So remember, we want to find the confidence level that's associated with this z star. Okay, so think about what we're finding. If you do a normal curve. Oops. Okay, so we have from here to here. So our z star, 1.55, all right. And this will be negative 1.55. Okay, so our z stars are always plus and minus. And then we want to figure out what's the area that's in between these. All right. Okay, and remember, finding area based on finding area is normal CDF. Okay, and when we do normal CDF, we'll just make this the lower and this the upper. Okay, and then that's it. So let's go back to the calculator to do that. I made a mistake, but let's see, I forgot. Second vars. Oops. Oh, I'm going to store this value first. Yeah. Okay, yeah, so B is that value. Okay. So now when we go to normal CDF, I can just use B and negative B, and that's what I did. Okay. Okay, so hopefully that makes sense. Whoops. Okay, so notice I'm using, so this is B is the negative 1.527 to 1.5527. So this will give us the area, this area that's in between these two z-scores. And remember, since these are z-scores, you have to use 0 and 1 for the mean and standard deviation. Okay, and then that's it. Okay, so this 0.8795, whatever, that's this area in between. And so that's the confidence level. Okay. So confidence level, we'll say is, maybe we'll round it to 88%. That's our confidence level. All right, and and that's it. I'll leave part B. Part B is explained in the answer key, so I'll leave people to do that. Okay, so that's it for this video.